Welcome to EnergiVerse Tech, your portal to the physics, engineering, and breakthroughs defining the future of energy. And before we build tomorrow, we must uncover the hidden truths of today. So if you're passionate about real science and next-generation technology, make sure to hit the subscribe button and join our growing community. We have been sold a clean, glittering vision of the future, silently absorbing sunlight, zero emissions, and endless free power directly from the sky, making solar energy the crowned savior of our climate crisis for 2 decades. But behind this green utopia lies a complex, uncomfortable reality of dirty mining practices, thermodynamic walls, and an impending tsunami of toxic e-waste that shows solar energy isn't as pure as it seems, making this an investigation into the hidden limits of today's technology and why a quiet engineering revolution is urgently needed. In Section 1, the channel intro and the perfect illusion. Moving into Section 2, the dirty root of clean energy. To build the world's cleanest energy source, you first have to do some of the world's dirtiest work, because every solar panel begins its life as quartz, a mineral rich in silicon dioxide, which requires extreme heat, up to 1900 degrees Celsius, powered directly by burning coal in most major manufacturing regions, causing a brand new solar panel to start its life in a heavy carbon deficit that takes 1 to 2 years of operation just to offset, while also producing hazardous chemical byproducts like silicon tetrachloride and hydrofluoric acid that can severely contaminate local soil and groundwater supplies if improperly treated. In Section 3, the thermodynamic trap, even if we overlook the manufacturing footprint, commercial solar panels convert only 18 to 22% of available sunlight into usable electricity, because silicon handles the full sunlight spectrum with extreme wastefulness. Low-energy infrared photons pass straight through silicon's 1.1 electron-volt band gap like ghosts to account for a massive 33% energy loss, while high-energy ultraviolet photons cause thermalization that wastes another 20% as excess thermal vibration, bringing silicon right up against the Shockley-Queisser theoretical efficiency limit of 33.7%. As explored in Section 4, the e-waste tsunami, with solar panels having an operational lifespan of 25 to 30 years and the global boom starting in the early 2000s, the world will face up to 78 million metric tons of decommissioned solar panels by 2050, according to the International Renewable Energy Agency. And because proper recycling costs around $20 to $30 per module, compared to just $1 to $2 for landfill dumping, simply discarding panels creates a ticking chemical time bomb of leaching lead and cadmium for groundwater supplies. Turning to Section 5, the next-gen revolution, recognizing these flaws is actually the birth of next-generation solar technology, where scientists are stacking miraculous Perovskite tandem cells on top of silicon to capture different light wavelengths simultaneously and push efficiency past 45%, developing transparent solar glass to turn skyscrapers into energy generators, and engineering closed-loop recycling systems capable of reclaiming over 95% of pure silver, silicon, and copper without fresh mining. Finally, in Section 6, Outro and Call to Action, solar energy remains one of humanity's greatest tools to power a sustainable future if we innovate past its current limitations. So let us know in the comments if you think next-generation materials like Perovskite will solve the clean energy dilemma in time. And if you found this video insightful, please give it a like, share it with fellow tech and science enthusiasts, and hit that subscribe button with notifications turned on to support our deep dive technical content here on EnergiVerse Tech. Thank you for watching, and we'll see you in the future.